So in this video, we will be talking about graphing equation of a parabola. So let's take, for example, this equation. It is an equation of a parabola which is already in standard form. So it is having square of x plus 3 equals negative 8 times y minus 1. So I'm going to teach you how to graph this. So first thing to do is to identify the vertex. So we're going to start with the x plus 3 equals 0. So where do we get this x plus 3? It is coming from here. That is the x coordinate of the vertex. So let's solve for x. So we subtract 3 on both sides to isolate the x to cancel this. So x is equal to negative 3. Now for the y, we're going to have y minus 1 equals 0. So this is coming from here. And we're going to solve for y. So we're going to add 1 to both sides to isolate the y, so we can cancel this. And what's left is y equals 1. So that means the vertex is at negative 3, positive 1. Now for the a is the distance from vertex to focus. So distance is always positive, so a cannot be a negative number. So how do we find a? So we use this idea that this is a form of a standard form, x minus h squared equals 4a times y minus k. So observe that 4a is actually the negative 8 on the given, but we will not include the negative sign anymore because a is just a distance. So it's, as I said, it's impossible for you to have a negative distance. So we'll just ignore the negative sign and put 4a is equal to 8. So you may ask where you get 4a. 4a is always 4a in the standard form that is fixed. So I'm going to divide 4 on both sides and to cancel out the 4 so that we isolate a, since we are after of looking for a. And a is equal to 8 divided by 4 is 2. So that means the distance from vertex to focus is 2 units. Now to find the focus, we are going to plot first the vertex in the graph, which is at negative 3, positive 1. And we're going to count 2 units from the vertex to get the focus. But the problem is there are 2 possible ways to have the focus. It's either upwards or downwards. So we look at the 4a. If 4a is negative, then our focus should be below the vertex. So we're going to count 2 units from the vertex going downwards. So it will be here. This will be the focus, which is at negative 3 and negative 1 coordinate. And then the latus rectums, it is actually from the focus going to the left and right twice of the distance of A. So that means the left side, we're going to have 4 units from the focus. That's the first latus rectum. And at the right side, the same thing, it's 4 units. Again, it's 4 units because it's twice the length of A from the focus. So that's how you find the latus rectums. So the coordinates for the latus rectums are negative 7, negative 1, and 1, negative 1. So it's important to get the latus rectums because these points will tell you how wide is the opening of your parabola. Next is the directrix. So directrix is it's a line that is opposite to the direction of the focus. So if focus is going downwards, then the directrix is going upwards from the vertex with the same distance a. So it's also 2 units from the vertex. So the directrix, or the equation of the directrix, is at y equals 3. So observe that we don't put coordinates because directrix is not a point, but it is a line. And we use broken lines since it is just an imaginary line. Now we're going to connect the vertex and the latus rectums so that we can form the parabola. So we can see that this parabola is opening downwards. It is downwards when the 4a, which is the negative 8 in our given, is a negative number. So if it's positive, it's opening upwards. Now, observe that also our graph is going up, opening upwards or downwards. That happens when the x is the one with the square. Now, how about if the y is having the square and the x is it's only x? So I'm gonna have that in our next example. Now let's have another example. In this case, we switch the y and x. So now y has the square. So that means the graph of this parabola will be either going or opening towards left or towards the right. So the first thing to do is to identify the vertex. So we're going to equate x minus 1 equals 0, the same procedure as the previous example. So we're going to add 1 to both sides to cancel this, and x equals 1. So that you're going to do the same with the y plus 3 equals 0. So we're going to subtract 3 to both sides to cancel this, and y equals negative 3. So that means the vertex is at 1, negative 3. So to solve for a, the same procedure as the previous example, we're going to have 4a equals 8. So again, we don't include the negative sign anymore because a is a distance, and you can have a negative distance. So we divide both sides by 4 to cancel, and isolate the a. So a is equal to 8 divided by 4 is 2. So a is 2 units. So the vertex to the focus is 2 units distance. Now to know the focus, we are going to start plotting the graph. We have 1, negative 3 for the vertex, and then 2 units going to the focus. So the focus can be at the right or the left of the vertex. So how to determine the direction of the focus? You look at the 4a. 4a in the given is negative 8. It's a negative number. So if it's 4a is negative, then that means the focus is at the left side of the vertex. So we're going to count 2 units going to the left, which is here at negative 1, negative 3. Then identify the latus rectums along the focus. So it's going to going upwards and downwards by twice of a, which is 4 units. So 4 units up, it's going to be here, and 4 units downwards from the focus is here. And the coordinates are negative 1, positive 1, and negative 1, negative 7. Now for the directrix, so it's going to be 2 units from the vertex going to the right, which is opposite to the focus. So it's going to be here at x equals 3. Then after that, we are going to connect now the vertex and the latus rectums to form the graph of the parabola. So here's the graph of this equation.